Good afternoon, everyone. Welcome to BDT201, Big Data and High Performance Computing State of the Union. My name is Ben Butler, and I'm the Senior Solutions Marketing Manager for both Big Data and HPC on AWS. So I'd like to welcome you to reInvent and learn an introduction to Big Data and HPC and some of the customer success stories that we'll share with you today. And so we'll go over the agenda. We'll first start with Big Data on AWS, talk about how we think about it and our portfolio of big data services, as well as some big data customer success stories. Then we'll introduce HPC on AWS, and then we'll have Ayumi Tada from Honda Corporation talk about their HPC journey. And then I'll conclude by going over all of the resources that we have available after the session or after reInvent for you to get started on getting on AWS. And then for a big data track review, I'll go over a few of the other sessions in the track. The track is about 21 different sessions that we have for you over the course of reInvent. And so I'll review some of those if you want to dive deeper on a particular service or architecture best practices. So big data on AWS. When we see big data or data flow, there's a certain life cycle of generation, the collection and storage, the analytics and computation, and the collaboration and sharing of those. And the phenomenon of big data has really put a lot of emphasis on the generation of the explosive growth of digital information. So your typical hockey stick growth curve of growing digital information from IT server logs, applications, web apps, audit logs, websites, mobile apps, wearables, Internet of Things, you name it. There is this tremendous growth of the generation of data. And not to mention social media and tweets and Pinterest and Instagram and the likes. Because there's a lower cost and a higher throughput of that generation, there's putting constraints on the rest of that life cycle of the collection and storage, the analytics and computation, and the sharing. And so those are highly constrained. And so when we think about big data, it's not just that generation of data, but more about when your data sets become so large, you're now innovating how you're collecting and storing and analyzing and sharing that data. And so when we think of big data, it's the technologies and the techniques for working productively with data at any scale that you need. And so what we try to do with AWS Cloud is provide those big data services and that platform so you can accelerate and remove those constraints at the generation phase and go through the rest down through the life cycle. So there are some compelling benefits to AWS Cloud as to how it relates to big data. So big data you could characterize as potentially massive data sets. But with the cloud, you have virtually unlimited compute, storage, networking, managed services. With big data, it's iterative, experimental style. You're trying to figure out exactly how you want to analyze that data or you want to process it. With the cloud, there's iterative, experimental style of infrastructure deployment. So it's pay-as-you-go, on-demand, provision capacity in minutes. And then with big data, it may be frequently not steady state, unpredictable, but large workloads with lots of peaks and valleys. The cloud is most efficient for highly variable workloads, being able to auto-scale up or down. And then time to results is key. So it's not just how great one particular server is at doing a computation, but it's really getting the time to results, the end to science or to research. And with the cloud, you can run multiple clusters or multiple workloads against the same source of data, namely, say, like S3 or Redshift or data warehouse. That way you can parallelize your compute, and it's more quicker to get to the time to results. And then with big data, it may be harder to manage and configure your big data stack, figuring out which of the solutions will work for you. But with the AWS Cloud, we offer a lot of managed services that take away that heavy, undifferentiated, heavy lifting of managing that stack for you. So we'll go through a high-level overview. I won't dive deep into each one, but I just wanted to give you a set of services that we've aligned toward that life cycle. So one of these, a couple of these that I'll point out is Direct Connect. So Direct Connect is a way to do a private fiber line in 1 gigabit or 10 gigabit increments and any number of those. So that's how you can connect privately to the cloud and securely. We also have AWS import-export. And we'll have another session, Mapbox, that'll talk about how they actually ship hard drives to our data centers, and then we'll upload them into the buckets for you. And then another one I'll talk about, I'll bring up is AWS Data Pipeline. Data Pipeline is a service that allows you to automate the movement and schedule how data moves over from different parts of our services or on premises. And what I'll do is now I want to dive deeper a little bit on some of these other services, specifically for within the big data portfolio. And I'll start with Amazon Kinesis, which we launched last year. It's our real-time streaming service. So you don't have to worry about creating a streaming service to be able to partition, and it can scale out to hundreds of thousands of different sensors, servers, different logs. So one example use case is if you have a IT infrastructure and you want to analyze the access logs or clickstream logs, you don't have to wait till the end of the day or a certain hour and do a batch processing. You can do real-time streaming, and you can send the events to Kinesis, and the Kinesis has a stream which then you can consume using something called the Kinesis Client Library. It's an application you can build onto EC2 or your own servers that can consume that data and do analytics, reporting, or store it into Redshift, do extraction, transformation, and loading. And it's easy to use, easy to be able to provision. And so now you can be able to collect, we see another growing use case of Internet of Things, being able to collect all data from different sensors and then being able to tightly integrate that through the rest of the big data stack. And it's hard to talk about big data on AWS without talking about Amazon S3. It's our foundational object store. It can store objects from 1 byte to 5 terabytes in size. Any number of objects. We have trillions of objects in there currently. You saw earlier today about the petabyte scale of just the transfer of data going in and out of S3. People that are doing big data platforms or big data workloads on AWS consider S3 as an elastic data lake, or a data lake is your single source of truth where you can put all the raw data or your ground truth source of information, of then which you can use EMR or Redshift or other big data services to consume that data. But S3 can scale to meet any type of demand of the collection and storage of data. And it's also designed for 11 nines of durability. And then Amazon DynamoDB is our NoSQL as a service. So it's running, you can do JSON or binary or strings and numbers and text into our NoSQL data store. And we just upgraded from 64 kilobytes to now 400 kilobytes per item, and it's schemaless, so it has lots of flexibility. So when it's very popular in mobile and gaming and large-scale applications such as those, and it offers single-digit millisecond latency, so under 10 milliseconds to be able to read and get that data in and out of DynamoDB. It's also really important for workloads in digital marketing where you're doing real-time bidding, where you're trying to figure out what kind of ad to place on which web property and what kind of profile you want to send that to. And those decisions have to be made in 200 milliseconds. So having that low latency, such as 10 milliseconds into DynamoDB, is very important for those types of workloads. And then Amazon Redshift is our petabyte scale data warehouse as a service. It is the fastest growing service in the history of AWS. It is a massively parallel columnar related database. It's fully managed, and if you use it for our reserved instance types, you can get it for less than $1,000 per terabyte per year. And it takes a few minutes for it to launch up instead of weeks of being able to launch a data warehouse cluster. It's also fully SQL compliant. It has connections to ODBC and JDBC drivers, and it integrates with a lot of the business intelligence tools that you may already be familiar with and working. And then when you also talk about big data, it's hard not to talk about Elastic MapReduce or the Hadoop ecosystem. So Amazon EMR is Hadoop on EC2 as a managed service. It has a lot of integrations into the rest of the big data portfolio, but also compatible with the Hadoop ecosystem, such as with Hive or Pig for ETL workloads, Impala or HBase for storage, and then it's also, it can scale to thousands of nodes. And so I wanted to give you an example. So if you have a lot of data in your own data center and you're wondering how I could leverage EMR or Hadoop in the cloud, one simple example is in your data center here that's gray on the left, you have those sources of files, maybe application data or logs that need to be analyzed. Maybe you need to sum them or find trends. What you can do is then use either direct connect, over the wire, over the internet, use open source tools such as Tsunami UDP, or use our ecosystem of tools such as Aspera or Globus Online, and be able to shift or move that data into S3. And then from there, or you can use import, export like I talked about before. And then from there, you start the Elastic MapReduce service, and there's a name node. And then from there, you can launch multiple clusters. You can have core nodes, which would run your HDFS. And then you can have additional task nodes, which will add additional compute to your cluster. And then you can scale to hundreds or thousands of nodes. And then when you're done, the beauty is then you can shut those. You're only paying those by the hour as you need it. And then you take the output of those mappers and after the reduction stage, and then you put that into S3. And then S3, then you can pull that back into your own data center for analysis. That's a quick way of showing you how you can use EMR in the cloud for your purposes, and then you can still use the leveraged infrastructure that you already have in your corporate data center. And so EMR is compatible with the Hadoop ecosystem, as well as you can decide that you want to run the Hadoop ecosystem set of tools on EC2 as yourself. You may have your own reasons why you need to integrate that and you want to do it on your own. One example I like to give is with Apache Spark. The founders, the creators of Spark have created a company called Databricks, and they have they've leveraged Spark on EC2, and they just last month they did a benchmark, the Daytona Gray benchmark, about how fast they could sort a terabyte of data, or 100 terabytes of data, excuse me, and they broke the previous record with Yahoo. Yahoo had, let's see here, 21,000 nodes, and it took them a little over an hour to do it. Databricks, in conjunction with AWS, they used EC2 with Spark. They used our I2 instances, and they had 206 nodes. So about a tenth of less compute in terms of nodes, but we're able to get that down to 23 minutes. And they were able to do that because of the agility of the AWS cloud, being able to access EC2, and then getting fast access with the SSD drives, and then the 10 gigabit network interconnect bandwidth between those nodes. And then they also did a petabyte scale, and they did that in a little over 230 minutes, and being able to sort basically like a billion trillion rows of data to be able to do that. And so now let's talk about certain use cases. As we found out earlier this morning, there hardly is any industry that hasn't taken advantage of the AWS platform. And I can say the same for big data specifically, whether it's in mobile or telecom, oil and gas, retail, life sciences, financial services, online media. And so what I like to do is go over a couple of case studies that we've had success with that we can go a little bit deeper on. One of them is Sling Media. They make the Sling box, which it's basically you can connect that to your TV, and it's a DVR that you can access remotely through your mobile device or tablet. They decided that they wanted to use AWS to store all the data that they get from the user interactions and the logs from both the devices as well as the apps. And they had to analyze terabytes of data. And so what they wanted to do is be able to do near real-time ad hoc analytics to determine what our customer preferences are, what they should do to innovate on the app, and they wanted to be able to have that capability to scale in their data warehouse immediately. And Vivaki is based in Chicago, or in Indiana, I'm sorry, and they are a digital marketing firm, and they run hundreds of thousands of campaigns. And so what they do is they had an in-house solution, and it couldn't meet the demand of analyzing petabytes of data from the hundreds of thousands of campaigns that they're running worldwide. And so they decided they wanted to migrate that over to Redshift, and then they could also correlate not just the clickstream analytics and the logs, but they also wanted to correlate that with geographic territories where they could actually have more targeted type of ads. When they did normal loading on premises, it would take them to take 6 months of data. It would take them almost 20 days to load it completely into their on-premises data warehouse. They were able to do that into Redshift by putting it through S3 and doing it in parallel in 6 hours. So they went from 20 days to 6 hours to be able to do that. And they were able to reduce their footprint where they can run this platform with 15 people, of which they used to, would estimate would take about 40 to fully run in-house. The News Distribution Network is a corporation that has created an exchange to be able to send videos for publishers and content creators to distribute out through different web properties, different apps, and it hits 146 million users a month. And they ingest over 100,000 videos, which they store in S3. They also do analytics of those 600 million content plays to determine, after you watch one particular video, what would be other videos that you would be interested in so you can see and that you can follow along with. If it's a particular news storyline or a show. And they also use Amazon Kinesis to analyze billions of those clickstream events constantly. And so instead of using logs traditionally, they're able now to do as streaming events going in. So they were able to, the COO said, using AWS has enabled us to build a solid platform that has scaled quickly while also becoming a profit stream for their customers, because now they give those publishers and content creators easier way to monetize their content with relevant ads. Financial Times is a large publication. It's used by over 37 of the top 50 business schools of their education products. They have over 660,000 subscribers. And they wanted to also be able to understand what were the trends, what were hot stories, what were people interested on, how long are they staying on those particular stories. And so they needed a way to increase the speed and performance of how they're doing that analysis. And furthermore, they needed to reduce the cost that they were doing. So this is an organization that's been around for over 100 years, and they wanted to change their culture to be more of a global digital organization, and they're using AWS to help them get there. And they were able to reduce their infrastructure costs by over 80% over what traditional data center model that they had estimated. And they were using Redshift to do queries, and the analysts were thinking that when they first started with Redshift that it wasn't working. The queries were coming back too fast. And part of that was they're used to starting a query, going and getting some tea, having lunch, coming back and seeing the results, but they were getting them in seconds or in minutes, and they thought that something was wrong initially. So they were very pleased with that, and they're making further plans to migrate more of their big data platform back on. NTT Docomo is one of the leading, or if not the predominant, mobile provider in Japan. And they launched a Siri-like service, a voice recognition service that sends a lot of audio files back into the system. They have over 60 million users that are using that system. So it's a lot of data to be able to process as well as to store. And so they decided they didn't want to try to maintain that, and it wasn't scalable to do it in their own center. So they decided to move that into the cloud last summer. And they were so pleased with the results of the low cost, the agility, the ability that we also have this global presence that we're in Tokyo, that their senior VP said, I can't imagine doing NTT Docomo without using AWS Cloud for that. Kellogg. So Kellogg is using big data on AWS. So it's not just startups or digital marketing firms, but large enterprises that have been well established have found success using big data platforms on AWS. And they did one where Kellogg usually makes about, in annual revenue last year, about $15 billion, and they spend about a third of that, so $5 billion, on what they call trade spend. And trade spend is doing coupons, promotional campaigns, shelf space, a lot of different targeted channels to determine to get more growth. And so they spend a third of their revenue just on that. So they're always looking for ways to, it's a high volume, low margin business, so they're always looking for ways to reduce costs, because 1% savings is a $50 million absolute dollars that they're trying to do. And they wanted to leverage their investments in SAP HANA, which they've already bought licenses for. So they decided that they wanted to be able to do two things. One is to reduce the cost of the infrastructure, but also make more relevant, more targeted, more efficient uses of their trade spend. And so they were able to do that. And one of the ways they do that, they run these different simulations. And on premises, what they were able to do is just run one simulation per day. They were able to go 30 times that when they moved over to AWS and leverage the existing licenses for SAP HANA, which are certified to work on AWS. And then the Baylor College of Medicine also uses AWS to accelerate analysis and discovery. And so what Baylor College of Medicine, they have this CHARGE project, and CHARGE is trying to figure out through genomics what's causing heart disease and aging. And so there's 5 institutions worldwide with over 200 scientists that need to collaborate on genomics information for 14,000 patients or individuals. And they just knew that trying to do this and shipping each of these genomics runs or sequences could be 5 gigabytes, 50 gigabytes. And so that adds up very fast if they want to do a lot of sequencing. So I'll show you a little bit about the architecture here. What they would do is in the Baylor College of Medicine, they would have the next generation sequences that would sequence the individual's genomes. And they would use, the partner that worked with Baylor is DNA Nexus, and they created a pipeline that utilized over 3 million EC2 core hours to process that data, being able to understand the sequences, pull out what the variants are, what are the things that could be indicators of heart disease or of aging. And then they would collaborate here with over 200 different scientists worldwide. So instead of trying to ship disks to over 200 scientists worldwide, they created a collaboration platform where the raw data is stored in S3 and it gets archived into Glacier. Glacier is our 1 cent per gigabyte per month cold storage service. And then they could use all the collaboration tools, so everything is running in the cloud. What we like to say is that data has a certain amount of gravity and inertia, and what happens is it's easier to pull the compute toward the data instead of trying to move the data all around. You move the compute to the data, and the cloud is a perfect example of that. One last big data example is with HG Data. It's a smaller firm that was started in 2010, and they provide competitive intelligence to the technology stacks of different companies. And the way they do that is they mine the internet, and they go to Career Builder, LinkedIn, different job postings, as well as the websites themselves, as well as news sites. And they ingest that data and they process it. They also buy proprietary data sources as well, and they fuse that together. And they crawl over billions of pages. They do dedupe, because a lot of these things are the same, over 10 billion documents with Amazon Elastic MapReduce. And then at the end result, they provide an API or a client that delivers the competitive stack. So we'll walk through this a little bit. Is that here's from the internet, they have 2 crawlers. One is from crawling the internet, and the other one is also getting the documents from private sources. And they store those files into S3, terabytes at a time. And then they use Hadoop and ETL analytics. And what they do is, for the first phase, they just cleanse the documents, format them into JSON format, and push them into a MongoDB cluster on EC2. And then from there, they ingest that into an Elasticsearch cluster, which is an open source search system that you can use on EC2 that will enable you to provide the indexing of all those JSON files. So it's easier for here, where they use Java and Python to implement their proprietary natural language processing and machine learning algorithms against this data. And then they cleanse that and put it into a relational database on MySQL, on RDS. And then from there, they package that data and serve it in 2 ways. One is an API to clients, and then also a web app to their customers. One story that the CEO told me was that One time there was a tech company that just announced that they were going to acquire another tech company, and one of their customers wanted to be able to send a targeted email to their list of the acquiring company, and they wanted to do it within 12 hours. In normal infrastructure, they would not have been able to index all the pages, do the machine learning algorithms, and be able to provide that targeted email campaign information to that customer. But with AWS, they're able to do it in less than 12 hours and to be able to get that out there. All right, now I'd like to do HPC on AWS. I'll just quickly go through this. You take a typical big data computational task, and the average cluster is either too small or takes too long to complete. You may have some algorithms that could optimize that cluster or complete that task in hand, but it takes forever to be able to do it. Or the other way is that for high performance computing, you may have this large data center, a large cluster, and you have this job, but it's overkill and it's too expensive. You haven't optimized your resources effectively. And then with AWS, you can balance it. So before, you'd have to tune the job to fit the cluster, improving the algorithms. But with HPC on AWS, you're able to tune the cluster to do message processing interface MPI workloads, computer-aided engineering workloads, and you're able to fit the job, fit the cluster to the job. So you don't have to worry about it being too large or too small, and also you can run multiple clusters at the same time. So a lot of the same benefits for why do HPC. You have this virtually unlimited infrastructure. You can have concurrent clusters on demand. You can increase the collaboration, and you can have more efficient clusters to be able to do that to get faster time to results. There's popular workloads, genome processing, computer-aided engineering, computational fluid dynamics for transcoding, for government, for computational chemistry. And just a quick note on scalability on AWS, it's the fact that you can go from a cluster that has 10 cores to over 1,500 cores, maybe a few minutes later, less than 10 or back to 600. You have this flexibility depending on your workload. And normally you would have to create a cluster that would be able to handle a little bit over the peaks, and all this white space would be wasted use of your infrastructure. Schrodinger and Cycle Computing did a computational, just to show about scale. They ran over 156,000 core cluster to figure out which chemical compounds could be used for solar cell development. And they're actually speaking later on today. The grad student, Patrick Saras, will give a little example of the science that they go into developing new molecules and how they're using AWS to be able to run those simulations. And then there's some cost benefits to the cloud. So you don't have to do that capital expense model anymore. You can pay as you go and be able to not pay so much for the infrastructure and the capital expense up front, be able to launch those clusters and be able to scale up and down as you see fit. There's multiple different pricing models. I'll just talk about one here is Spot. Spot is the capacity where we have extra capacity and you get to bid on it. And you could create a large scale cluster just like what Cycle did with Schrodinger, that you can leverage hundreds of thousands of cores, and if no one's using them, we'll sell them or rent them out for pennies on the dollar or 90% savings, and to be able to do that. So one of the things you have to architect for is that if that market price goes up, you lose access to that instance, so you have to handle for node failure in your workloads. But it's an innovative pricing model. And then when you consider HPC, is you're either starting something new, or you have a new idea that you want to do, or you want to figure out how do you want to extend into the cloud, or you have a hardware refresh, you could consider using Amazon EC2 instances for HPC. And then I like to give one more quick example of HGST. They're also speaking later on in the session, later on in the track, how they just did a run this weekend, over 70,000 core run. They did it in 8 hours to process 1 million different drive head designs to be able to simulate and be able to do that. And with that, what I like to do is now introduce Ayumi Tada from Honda, who's going to talk to us about their HPC journey on the cloud. Thank you, Ayumi.
Check. Okay. Good afternoon, everyone. I'm very happy to see so many of you here today. My name is Ayumi Tada. I work for Honda Motor in Japan. It is my responsibility to improve our engineering HPC system. I'm not good at presenting in English, so I'm a little nervous. But at the same time, I'm very happy and excited to be here today. Oh, sorry. I ask you understanding. Today, I would like to talk to you about our experiences and plans for engineering HPC systems in the cloud. First of all, let me introduce our company. Honda has many products, such as automobile, motorcycle, power products, and aircraft, etc. And we are a company built on dreams. These dreams inspire us to create innovative products that enhance human mobility and benefit society. We see the power of dreams as a way of thinking that guides us and inspires us to move forward. Our business model used to be individual optimization. So we had each system which was suitable for each area and each product, including our engineering HPC system. Our main R&D center are in Japan. They are in different places for each product, and they had individual HPC resources at every R&D center. This model was very effective for our company growth. However, we had to improve our business model, and we had to think about overall optimization and globalization, because cross-functional cost reduction and information linkage are the key to our business to optimize material purchasing and production. We also had to improve HPC resources. So we consolidated HPC resources. Next, I'd like to talk to you about why Honda started to using cloud and AWS for HPC. Again, Honda has many products, so our researchers and developers are using over 100 applications in total, and they request various types of servers which are suitable for each application. One user said, "We need more memory." Another user said, "We don't need more memory. We need more cores." Besides, they cannot accurately predict the number of cores and when they need it. We cannot handle all requests on premises. I guess this is not Honda specific. So we considered to use cloud for the request that we cannot handle on premises. So why did we choose AWS? In the summer of 2012, our users who belong to fundamental research suddenly requested over 100 nodes for a certain period. Though we have a lot of cores, but it was difficult us to respond to such requests because we have to prioritize our development. However, fundamental research is also important for us. We should respond to their request. That's why we looked for extra resources. We compared several cloud services. These were 3 decision-making factors as to why we choose AWS. First, read time. Second, agility. Lastly, services. Especially, we like EC2 Spot instances. Spot is a very attractive service, which differentiates AWS from others. Let's move on to our current situation. Honda's CAE on cloud is just at the beginning phase. So we built a very, very simple architecture and use a scheduler combined with our current API. Users access the cloud by using SSH through VPN. And they choose Spot or on-demand instances and submit jobs to the scheduler. After that, execute our API, run on the computing nodes, and executing the calculation automatically. After the calculation, computing nodes terminate automatically. I would like to show you our benefit. First, we were able to reduce total period spent on computing by utilizing cloud to 1/3, compared to utilizing on-premises alone. Second, one user can use over 16,000 cores at one time, even though there is a physical limit to capacity in the cloud, but it's so high capacity, we don't have to worry about it. Finally, by combining Spot instances with on-demand instances, we were able to save 70% cost saving. 70%. Spot is very reasonable, and it is suitable for some use cases. Combination of Spot and on-demand was most suitable for our use cases. While promoting our plans, we noticed that this cycle is important for us. I think this is a hint for you who are trying to use cloud from now on. Cloud should be formed by user request. So anyway, let's try. You can get result. Don't worry whether it's good result or not. Not good result will be part of your know-how and important for the next step. Even if you don't get good result, you can request to AWS what you need. Cloud services are still growing. After that, AWS will respond to it, and they will release new services. And sometimes I am asked the reason for using cloud. Why is Honda using cloud? Honda has many resources, doesn't it? Is it necessary to use the cloud? My answer to this question is having many resources on premise is not necessarily advantageous. Competition is getting intensified due to the cloud. You know, in the past, those who don't any resources could not calculate and could not use HPC easily. But it is difficult now. Even though who don't have any resources at all can calculate, they can use HPC easily. That means cloud is useful for everyone, but at the same time, it's also a threat for a big company like Honda, because small company which couldn't not afford big initial investment are now getting competitive thanks to cloud. But the cloud offers us an opportunity too, as we can innovate faster than before. So, though a big company like us has many resources, we have to use the cloud efficiently. We must keep improving our environment. Once again, Honda's CA on cloud is just at the beginning phase. We are executing this cycle. We keep trying to use several kinds of computation, such as CFD, toward the next step. We are getting some results and consideration points and giving feedback to AWS. Especially, we hope that interconnect network speed between nodes will get better than the current services. At the same time, we are considering to improve our operation to expand cloud usage for our computation. We will continue to increase adapting the cloud into our CA environment efficiently. Finally, let me introduce our company's founder, Soichiro Honda's word. Instead of being afraid of the challenge and failure, be afraid of avoiding the challenge and doing nothing. I would be happy if my today's presentation can help you in some way. Thank you for your attention. Thank you.
Thank you. Thank you very much. I appreciate you coming all the way from Japan to tell us your story. I know we're running a little late. I just want to go over a couple of getting started on AWS resources. We are here to help. We have a kiosk with solutions architects and professional services that'll be able to help you. We also have reference architectures that you can download and see. You will get slides of these, so if you don't get all the links, we'll make sure that we'll give you the slides. We have more case studies to show and see if they're near your workloads or your industries. And then we also have a big data competency part. We work with big data partners that have had successful big data workloads on AWS. And then we also have a marketplace where you can download solutions from the big data and HPC category, as well as a public data sets. We have the 1,000 Genomes. We have the Common Crawl, which is a nonprofit organization that crawls through web corpus that you can get and download and use for free. We also have test drives. You probably noticed the Lamborghini out in the front. We have test drives that you can use with no commitment. And they're also run by our partners. We also have a very technical big data blog that shows you how to use different services. So that's blogs at aws.amazon.com/bigdata. We have here an example post of learning how to use Apache Storm. And then we also have training. We have online training called the Big Data Technology Fundamentals. And then we also have big data training, which is a 3-day course. And then for the track, I won't go through these. They'll be in your app. But we have lots of customers, different stories. They'll share their lessons learned. And then please visit us at the kiosk. So we're here. As soon as you go into the expo room, it's on the near left corner. And then with that, thank you very much. I appreciate your time and your patience through this, and I hope you have a great reInvent. Thank you.